Good day. Today, I will talk about an experiment that turned into a practical development approach. The title may seem ambitious, codeless programming with AI, but I'll show you how it works in practice. It all started with an idea for a demo application. A seamstress had developed an innovative method for bra size selection, using a special measurement technique that significantly improved accuracy. She needed help creating a proof of concept. I was part of a development team, with my responsibility focused on the API. What's interesting here is that the initial task description was, let's say, non-technical. As is often the case when an expert in their field explains something to a programmer, there were many specialized terms, professional jargon, and things that seemed obvious to her but not to a developer. We had to transform the stream of expert knowledge into structured requirements. When we talk about modern development approaches, test-driven development, TDD, is a fundamental method where we first write tests describing the desired code behavior, and then create code that matches these tests. But there's a natural evolution of this idea, behavior-driven development, BDD. In BDD, we start by creating structured descriptions of functionality in a specific format, which then guides the creation of tests, which in turn guide the creation of code. Today, I'll show how this layered approach, combined with AI, helped create a working application with almost no manual coding. And it was at that moment I decided to test an idea I had been considering for a while. Could AI write the code based solely on a well-crafted task description? And the answer was, yes. An important point about the context. Initially, I wrote the code in the traditional way, but when I decided to apply AI, it rewrote the entire code base from scratch. This happened 8 months ago, using the Claude AI. What's fascinating is that even then, AI was advanced enough for this approach. And I want to emphasize, this was not some polished, automated process. I was literally copying text between the code editor and the chat window with AI. But the key point is, it worked. And now, 8 months later, I use elements of this approach in my day-to-day work where it's appropriate. The operative word here is appropriate. We'll discuss in detail when and where this approach makes sense. What makes this experience particularly relevant is that it highlights an essential point about AI and software development. Sometimes, clarity of requirements is more important than the complexity of the tools. Before we dive into the details of how this approach works, let's quickly review the architecture that made it possible. Our server is built on the principle of independent modules. For example, one module receives measurement data, processes it, and returns the size. Another collects customer feedback about sizing accuracy, and so on. The key point here is that each module is a separate, isolated piece of code. It doesn't depend on other modules and is responsible only for its specific task. This architecture allowed us to break down a large task into small, clearly described subtasks. And this, in turn, was perfect for working with AI. But more on that in the next section. Let's examine how this development process worked in practice. The traditional development process typically looks like this. Get requirements from business. Write technical specifications. Write code. Write tests. Debug and refine. The AI-assisted approach I used was different. Transform business requirements into BDD scenarios. Feed these scenarios to AI to generate tests. Use the same scenarios plus tests to generate code. Review and validate. Use AI to create user documentation. The key difference? The focus shifted from writing code to describing what needs to be achieved. Here's a practical example from this task. The seamstress explained. If the difference between underbust and bust measurement is larger than 10 centimeters, but smaller than 26 centimeters, we need to determine the cup size. And if the value hits the boundary between sizes, show both sizes. This was transformed into a BDD scenario. I created a Claude project containing all tests, code, and API documentation. This means every time I start a chat with this project, it already remembers all the information we need to proceed, and there is no need in additional input. Once the files are uploaded, I can ask Claude to generate tests based on these scenarios. Let me demonstrate. First, I provide the task definition. Based on given scenarios, generate new tests for relevant modules. Note that constraint I added to the prompt. I want to keep AI as quiet as possible and receive only the code without any comments. Second, I add the new BDD scenarios we talked about and send the prompt. Since AI's knowledge base already contains all necessary information, it will be easy for it to find a relevant test module and detect missing tests. As you can see, Claude created well-structured tests directly from BDD scenarios. Each scenario can produce multiple tests to reach 100% coverage. You can ask AI to generate specific chunks of code to copy and paste them, or write the whole test file and download it. This demonstrates three key benefits. Well-structured requirements directly transform into code. AI handles routine coding tasks. Human focus shifts to defining clear requirements. After the tests are ready, in the same window, we can tell Claude to modify the code to match these tests and scenarios. As you can see, in this case, AI decided to output all the code. You may ask it to output only changes and copy them into original file. In any case, all you need now is to do code review and then run the tests to make sure everything is still working. This is how I built the entire API. And while I'm showing the ideal scenario here, it wasn't always this smooth. Code still needs review and validation. However, once the process is established, it moves very quickly. Let me give you a specific example. Early in the project, adding a new error code could take several hours. This involved refining prompts, teaching AI the desired coding style, many trial and error iterations. By the end, the same task took just 30 minutes because the process was streamlined and partially automated. This shows how initial investment in setting up proper AI interactions pays off in significantly reduced development time. And yes, there was 100% test coverage. In the same fashion, we can ask AI to apply the necessary changes to the existing API documentation and keep it always up to date. Let's examine when this approach works best. Good fit. Small, isolated functions. Clear business rules. Predictable input-output. Lots of similar patterns. Less effective. Complex UI logic. Integration with external systems. Novel algorithms. Heavy async operations. The key is modularity. In our case, each function was a self-contained unit doing one specific thing, like calculating cup size or validating measurements. The rules were clear and the outputs predictable. This allows us to treat code fragments as a black box, where behavior is defined through scenarios while the implementation is left to AI's discretion. It can even periodically refactor the code without changing the system's behavior. I'm experimenting with incorporating this approach into my work, though this is naturally complicated by our extensive legacy code base, which can't be handled this way. However, for creating specific class methods and especially for writing tests, this is quite viable. The API is perfect for this methodology. Experience also shows that this approach is much simpler and more effective when applied to front-end development compared to back-end. It's important to note that the approach I demonstrated, copying code between chat windows, while effective for proving the concept, isn't optimal for long-term development. A more promising direction is the integration of AI tools that can directly modify code, tests, and documentation based on user instructions. This capability is already beginning to emerge in modern development tools, and here are just a few examples. GitHub Copilot has become so effective that several dozen% of code on GitHub is written with its assistance. It can analyze the entire project context and suggest relevant solutions. Windsurf AI IDE is an integrated development environment with a built-in AI assistant. According to colleagues who use it in real work, it's a very promising tool. I personally use Claude AI now. While this tool has limited scope and doesn't see the entire code context, it effectively helps with writing specific lines of code. Regardless of the tool used, it's crucial to remember about quality control. I always review the generated code, run tests, Ask the AI to make changes when necessary. With experience, the process becomes more efficient. I get better at formulating tasks and more accurately assess AI capabilities. In conclusion, I want to emphasize several important points. First, while this approach is already applicable for certain tasks today, I expect that as AI and programming tools evolve, the complexity of problems we can solve this way will only increase. Quality documentation and clear task definition are becoming increasingly powerful tools that can significantly reduce development time. Second, and this is particularly important for my fellow developers, programming is just one part of our work. Its quality and efficiency directly depend on the preliminary stages where BDD proves its effectiveness. Our job titles aren't programmer, but software engineer or developer for a reason. Delegating routine tasks to AI doesn't eliminate the need for expertise. If anything, it emphasizes it. We need to be experts to evaluate the quality of results and guide the development process. Generated code without expert assessment has little or no value. And one final note. This presentation itself demonstrates both the potential and limitations of AI. While it was entirely generated by AI, from the script to the video created by HeyGen, it couldn't have been created as you see it without human guidance. The initial outputs couldn't simply be copied and used as is. I had to guide the AI, request changes and improvements, and sometimes completely reject and demand revisions. This perfectly illustrates the symbiotic relationship between AI tools and human expertise, each playing to their strengths to create something better than either could alone. Thank you for your attention. You can find a list of the tools mentioned in this presentation in the video description.